Hello, everyone, and welcome to our webinar. This week's topic is Shift Left with Artifactory Pro X. Before we get started, I'd like to touch up on a few housekeeping items. First of all, the webinar is being recorded and it will be made available to you afterwards. If you have questions, please be sure to use the Q&A panel. This will help us better follow up during the webinar. It'll also help us follow up afterwards if we don't have time to get to your questions during this live webinar. Last but not least, if you're interested in trying out some of the things we're doing here, you can spin up a trial by going to jfrog.com, and you could do that for both on-prem and our SaaS offerings. We'll go over in some more detail later on how you could do that. Now for some news and announcements on the JFrog front. We have recently won awards in the DevOps field for our Universal Binary Repository, Artifactory, and our leadership, CEO Shlomi Benheim. You can check out the details by going to devops.com. We are also offering discounted passes to our annual user conference, SwampUp. You can save up to $700 if you purchase the full conference pass by February 28th. Many of you have probably attended previous conferences and know what to expect. But for those of you that haven't had a chance, this is a truly unique conference. The conference offers training, announcements, and the opportunity to know what's next from the top tech players in the DevOps world. With that out of the way, let's go over our agenda for today. First, we will start out with a brief overview of a typical development and release pipeline to give some context to what we mean by our shift left approach. We will explain what shift left means in terms of security and how it can be beneficial. We will then show how you can use JFrog Xray, Artifactory, and the ecosystem around it to accomplish the goal of shifting left. This will lead into a short practical demo of Xray in action. We will also cover one of the newer tools JFrog offers, which is Xray, a tool for monitoring pods in a Kubernetes cluster. This is a particular interest to anyone using Kubernetes or thinking of using Kubernetes. Lastly, if we have time, we'll go over some of your questions. Let's start with a review of a typical development and release pipeline. Here's an example of what a CI/CD pipeline might look like. This is a CI/CD pipeline without Xray. It starts with the developer writing or modifying code. Since no one writes everything from scratch, the process will invariably involve declaring various dependencies. Now, these might be dependencies on other libraries you wrote or third-party libraries. After making changes, the developer builds the code locally, pulling all the required dependencies from Artifactory, which it in turn grabs from external sites. After verifying that the build works, hopefully, the developer pushes the changes to a version control system. This in turn triggers a build in the CI or the server, Jenkins, for example, or whatever you happen to be using. This once again produces a build requiring those same dependencies. If the build is successful, the resulting artifacts are pushed into Artifactory, along with some important metadata, such as the build server version, the tool version, and additional variables that'll help you reproduce that build if you need to. From here, the artifacts can be QA'd by any process you may have in place, whether this is automatic or manual testing. Assuming it passes those quality control gates, the final result can be deployed to production or sent out for distribution. Let's look at a simplified version of that previous diagram. Here we have boiled down the CI/CD process to 7 steps and 4 different stages. The further in the process we get, the more expensive making changes becomes. This is true of any type of change, but it is especially true for security and licensing issues, since those normally involve changing third-party libraries. The problem with the setup we have here and in the previous diagram is that the first chance we have to detect those security and licenses issues is at the QA level. At that stage, having to work our way back to the code that is causing it can be costly, both in time and in effort. Let's go back a few. Even worse, if QA does not catch it and we ship it or put the code into production, the people first noticing these issues could be the consumer or malicious users. That can happen here. So as you can see, the further we move away from the developer, the more expensive the consequences can be. This brings us to the shift left approach to DevSecOps. What does shift left mean for us? For us, it means to inform and empower as early as possible in the development process. It means that if we are going to fail somewhere in the pipeline, we should fail as soon as possible. It is also the understanding that new security issues are discovered every day. And just because there's nothing detectable in our build today does not mean there won't be in the future, even after we have sent it out to our customers. For this reason, we need to start a breadcrumb that will allow us to trace newly discovered issues back to the source. Let's go back to our CI/CD pipeline, but this time with Xray. For the most part, the pipeline looks the same, but we have added Xray, and with it, a wealth of information and scanning capabilities. Out of the box, you are getting component and vulnerability data from a wide range of sources. These include NVD, OS package level sources, and more. We are also working with integrating VulNDV to expand our coverage even further. This new integration will add a little bit under 200,000 vulnerabilities, including 64,000 not already found in NVD. But even better than making that information available is the scanning capabilities. And with it, the ability to shift left in our pipeline and when we first detect issues. We can now detect the issue before it gets to QA. As soon as the build server deploys to Artifactory, it will be scanned along with any embedded components. This, along with our build integration, allows you to fail the build and provide information on what exactly caused the failure, be it a security issue or a forbidden license in one of the components. But why stop there? The code written is typically only a fraction of the code used. The vast majority of code and the likely culprit of potential exploits or licensing issues are third-party libraries. Xray and the ecosystem around it allows us to detect these as soon as the developer decides to use them. This informs the developer early on in the process, at a time when it is easy to switch to a newer version or an alternate library that doesn't manifest the problem. So let's go through a little demo and show some of those things we've been talking about. Let's start this demo off using the JFrog Xray homepage. From here, we're able to access a wealth of information, such as what components have been scanned, what violations have been detected. We can also configure various things, what webhooks should be used, what notification should occur, essentially what should happen when a violation is detected. But the main point of showing this is to explore the two major capabilities of Xray. These two capabilities are what give Xray the ability to shift left. Those two abilities are primarily, one, the ability to do a deep recursive scan. Now, a deep recursive scan is the ability to look at a single component and drill down and see what this single component is made out of. So let's go look at something more concrete. Let's look at a Docker image. Now this Docker image, web service version 1.0, has various issues with it. Both security, both high, medium, low types of issues. And we're also able to see the types of licenses that are associated with this particular image. Now we say types of licenses because while the image itself may have a particular license, certain components inside of it may have different types of licenses. How are we able to get this information? Well, that's where the deep recursive comes in. Let's look at the descendants. So in order to build this descendant graph, we scan the component and we drill down to the components that it's made out of. A layer below the image itself are the layers. So you can see here, this is the operating system layer. You can see that there are several RPMs, which makes sense. This is a CentOS-based installation. And if there are any known issues with any of these RPMs, we will know that they are associated with the image. Let's go ahead and close this down. Let's go look back at security. And we can see here that in fact, one of the components, one of those RPMs, does have an issue. But we can also see this common file upload, which is a Maven artifact, not an RPM. How do we know that? Let's go look back at the descendants. So as you can see in the other layer, there are several Maven artifacts. There are multiple versions of this commons file upload, and there's this Jetty installation, which in and of itself has various other Maven artifacts. Now, any of these can have vulnerabilities, and if they do, we will know about it. What's more important, this deep recursive scanning allows us to build a graph. And with this graph, we can do what the second major version of Xray is, which is impact analysis. Now, impact analysis is going the other way, essentially. Let's look at a particular component. So right here, we're looking at the commons file upload version 1.2. By the way, we're also able to see all the other versions of this particular component, as well as those available publicly, but not yet cached in Artifactory. But the impact analysis allows us to see who or what is using this component, and particularly which of our artifacts are using this component. So let's go look at ancestors. Here we can see that this component is in 2 layers. One of those belongs to the web service image we had seen previously, but the other layer is in various other images that we did not know, but now we do. That is impact analysis. We're able to see that if one small component is affected, we're able to see everything else that is impacted by that. Let's go look at a practical use case of this information. Here we have a fairly common setup. We have a Java application using Gradle to build and the IntelliJ IDE. We are also using JFrog Xray IntelliJ plugin. Now this plugin is going to provide various things out of the box. And let's just go ahead and look at some of those. First of all, we should see that this Java application has various dependencies that have already been declared. We have the commons.io library, Oshi, and JUnit. There are two major things that are being provided here. The first is license info. Out of the box, we can see what license those dependencies that we are using rely on. What's more, we're able to see transitive dependencies, as in dependencies of our dependencies, and their associated licenses. You're also able to filter. Let's say you prohibit certain types of licenses, you can see if those licenses are being used. So already the developer is going to have a heads up to what's going on. But let's go look at the Issues tab. The Issues tab is what allows the developer to know if there are any security or license compliance issues without him having to do work. How does this work? Well, you can set up policies in Xray that will prohibit certain types of licenses. The security issues make sense. If there's a known issue with the library, that will pop up. So let's go ahead and look at the code we have here. We have this upload method. And since I'm not going to write my own upload method, I'm going to use the library to do it for me. And I just so happen to know of a library I've used before. So let's go ahead and add it to our dependency so we can use it. Let's refresh the project. Let's rebuild it. We haven't actually used it yet, but okay. So let's see what information is available. So as you can see here, already something has been picked up. There are several issues with this particular library, some of them with the severity of high. There's also a summary of that particular issue, the type of issue, and the component that is affected. Now, we already saw that there are various versions of this particular library, and we know that there is a good one we can use. So let's go ahead and change it. And refresh it. And as you can see, we are green and good to go. Now, for this simple application, you can already see how this can be tremendously helpful. We have informed the developer right away before he even used the library that it's something that has known issues. At this point in the process, it is very easy to make a change to a library that doesn't have any issues. Let's go ahead and switch back to our deck. The demo you just saw was done with a trial version of JFrog Xray Online. If you're already using a hosted version of Artifactory, this is the natural option for you. You can choose to add Xray trial to your existing Artifactory SaaS or have a new one spun up. If you are using your own installation of Artifactory, you can also get an on-premise trial. In either case, the features will be the same. So far, we have seen how Xray can help you detect issues earlier in the development phase. This is great for detecting issues that we currently know about, but security issues are discovered every day. Xray's impact analysis, that we saw earlier, can alert you to newly discovered vulnerabilities in your software or its dependencies. And Cube Xray is a tool that makes use of these capabilities in a real-world application. So what exactly is Cube Xray? Cube Xray is an open source project. It actively monitors running pods in Kubernetes by listening to events from the Kubernetes API. It then uses the data provided by JFrog Xray to make sure the security and license policies you set up are being met. If the conditions are not being met, the tool can scale down your deployment to 0, delete it completely, or simply ignore it and notify you. If we go back to our chart, we get a clearer picture. Imagine that a 0-day vulnerability is discovered in a library your image uses. A 0-day vulnerability would be one that is essentially discovered today for the first time. Xray identifies the vulnerability in the library, runs an impact analysis, and detects that your image uses this library. Xray then detects that your Kubernetes cluster has a deployment with this image. At this point, it will stop it, delete it, or alert you, depending on how you set it up. So let's see that on the slide itself. We detect it here. But thanks to the combination of Artifactory and the Xray metadata and that breadcrumb we talked about, we're able to trace back to when the vulnerability was first introduced. And that is what we mean by leaving a breadcrumb. So what have we seen so far? So far, we have seen, one, how the developer can be empowered early on in the process and make changes when they're least costly. Two, we have seen that Xray can detect vulnerabilities and stop them at the build level. And three, we have shown how we make use of the breadcrumb that we build to trace back new vulnerabilities back to their source. Let's go ahead and answer some of your questions now. We don't have much time, but it looks like we do have some questions regarding VolNDV, its usage. So we'll go ahead and address that right away. So VolNDV is expected to be integrated into Xray core. In other words, there's not going to be any additional cost to you, the Xray user. The way it'll work is the new vulnerabilities will be added to JXray, our primary database for Xray, and you will, as the user of Xray, automatically receive those. It looks like we're all out of time, unfortunately. We will get back to all those other questions offline. Thanks.